Everyone's really tired. No one wants to do anything anymore. UCMO, I can tell from the UCMO grading as well, and just everything in general, like no one has any energy. I've been completely dead as well. Alright, so how do I do this, and what is this? So... do I want to do this? Okay, let's see. Why is there a prime condition? That's my first question. Like, why is prime important? The statement looks like it's only about size, but then it's talking about some prime. Okay. Why would it matter that it's prime? Also, what is the answer? So, okay, what the first dumb thing I should say is root x plus root y is, let's see if I can get this right, less than or equal to 2 root x plus y over 2. Okay, that's not the way I wanted the inequality to go. So this tells me that I'm not really going to get much of a... Wait, is that the way the inequality points? Yeah. Yeah, I am so confused that there's a prime condition. Like, it doesn't seem like prime has anything to do with this size, but apparently it does, so... we're gonna find out why. What if you solve for y in terms of x? That's not a bad idea, actually. Let's do it. So root y is supposed to be less than or equal to root 2p. Okay, that might give some plausible reason why. Yeah, it's sort of like there's a fixed x and then there's a y that maximizes it. And so if I square both sides, it's like 2p minus x minus 2 root 2p plus x minus 2 root 2px. Did I want y to be the bigger number or the smaller number? I feel like I should flip it, right? If x is at most y, then I kind of want x to be the smaller one. The one I'm solving for? Yeah, so I don't want to flip these. Y, x, y, and y. Yeah, so obviously we want y greater than p. Actually, hang on. Okay, I guess prime makes sense actually because there's integers involved. Okay, it's not that terrifying. Do I want to solve for x or y? I'm not sure. Because I was gonna say if y is greater than p, then maybe x should be less than p, but I think that's just false. Well, I don't think that's true. Okay, well I wanna look something up because I remembered something from a long time ago. What is the answer? I don't know. No, I don't. Okay, well, if p equals 3, is that true? 1, 2? No way. Really? How is 1, 3 not better? No. Hang on. Oh, wait. No. X equals Y equals P does not work. What am I talking about? Okay, never mind. I'm just completely confused in the head. Okay, yeah, okay, let's just do some small cases and figure out what we're going after. So this is where I get to do lots of decimal approximation, right? Right. Yeah, so when P equals... I'm gonna first approximate the first several square roots for my reference. So 2 is 1.414, don't ask me why I know that. 3 is 1.732, don't ask me why I know that. Root 3 is 4 is 2, I definitely know that. Root 5 is 2.3, no, 2.236. I know that because I remember 1.618. Root 6 is something. So if I multiply 1, 2, 4, 2, 2, 4, 2, 4, 8, 2, 4, 2.449. No, I'm streaming. Okay, and I have no idea what root 7 is. Root 8 is 2 root 2 though. Root 9 is 3. Root 10 is the product. So the good thing is the composite ones I can compute by multiplying the decimal approximations, but the prime ones I actually just can't get, which is kind of awkward. 12 is 2 root 3, so that's like 3.464. And root 13 is whatever, and then root 14 is something. No. Oh my god. Okay, anyways, root 10. What is root 10? Root 10 is 2, 4, 8, 8, 31304, 3162. Can you explain step 3? Which step 3? What software are you using? Whatever I wrote up. There. Yeah, so from here to here I just squared both sides, that's all. I think I miscomputed root 5. 24248 is what I said. No, that's fine. And then root 5. Okay, okay. Yeah, I didn't put a new line. Root 13 is root 14, everyone. That's what we love to do. Okay. So, anyways, oh my god, I really need root 7, don't I? I think I'll only get like 2-ish digits before I run out of computational power. 7. Why I know how to take square roots like this? Don't ask. No, I'm actually doing the square root algorithm, which it does exist. Yeah, so you know how when you do long division, you can like, you know, get one digit at a time? You do the same thing with the square root. Basically, you compute the partial sums at every point, and you like take the largest digit that doesn't make it overflow, which is not very easy to implement, but you can do it. I think I'm messing up though. Oh god, I can't do this in my head anymore. 4, 12, 12, 2, 4, 2400, 260. Hang on, no. 4, 12, 12, 36. Add 2 more digits, 2400. 2400, about 12. 4. Okay, 304 is the remainder, and then 30,400. You know what? That's good enough. Okay. Okay, and now I have to do root 11 because I need that data. 3. Okay, so I think I'm messing up. How did Euler discover so many things in so many areas of math? Well, Euler is pretty competent, I guess. Nine, 1100, 330, 660, 439. Okay, I'll just stop there. 3. 40. 400. 30 over 400 is about 13, so I take 6, 40. Clear by 4,000 over 360. Five. It's okay, good enough. It's about 3.74, I think. Okay, these. Let's hope. Someone yell at me if these are like really far off. Wait, actually, I think I messed up the 13. I think I'm off. I think it's just truncated 0. Okay, so now that I have this data, let's work out. So p equals 2, p equals 3, 6. Yeah, 2 point root 2 plus what? Root 1 plus root 2 is probably as close as I'll get. And when p equals 5, 3.612, can I get... How do you do this? Okay, so I don't want to use anything that's bigger than like 2, right? Or I can get 1 plus 4 is 3. I want to do better. Oh my, root 2 plus root 3 is so close. It's like 3.146. That's like within, like, did I screw up the arithmetic range? Yeah, that's actually within the realm. So I know the root 2 and root 3 are exact. I don't know about the root... Well, this should be correct actually, because this is exact up to like 0.002 error. And then these two multiply, so the error is at most like 0.005, I think. Okay, so I think this is safe. But holy crap, that was close. And 14 is like, because I couldn't compute root 14 exactly, I may not know. But based on this, I have a pretty good guess what the answer is going to be. Oh wait, no, hang on, what? No, I don't have a guess. What is the 1 for 7? P equals 5, root 3 plus root 4. Did I mess? Oh, sorry, I meant root 2 plus root 3. which is so close that it has to be right. So p equals 7 is probably root 3 plus root 4, right? In that case. And p equals 11 will be... Oh, okay. Okay, so yeah, that looks like it's gotta be that. It's gotta be that. There's no way. But why does 9 not work? Like, if this is just... If root... Like, root 4 plus root 5 exceeds 9. What does being a prime have to do with it, though? Like, I don't see how being... This can't keep going, right? Like, if p equals... Even if p equals 11, 5 and 6... Oh, sorry, it's 18. 4, 5... 4.6... No, it's too big. Like... No, it's fine, actually. 4, 2, 3... No, it's okay. Okay, so anyways, the claim is that root... Let's first check that this is actually always less than or equal to, and then try to show that the error margin is close enough. So the claim is that for any... This should be true for any integer if it's true. The claim is that for any real number p that's not too tiny, any odd real number p... Well, just, what does odd real number mean? Yeah, the claim is that this should be true. And I can prove it by... Isn't this just true? This thing... Yeah. So it's fine. This is correct. Yeah. Yeah, so this is just true. Like, right, this always true, regardless of whether p is prime. So the bulk of the problem is going to be showing that you can't do better than this when x and y are random other integers. Okay, so I can probably hide the arithmetic then. Okay, so now we know the answer. I probably didn't actually need to compute all those things to guess that was what it's gonna be, but now we're here. So we want to show the following is impossible. We want root x plus root y should never be strictly between square root 2p and between root p minus 1 over 2 plus root p plus 1 over 2. We want this to never happen for integers x and y. Dang it. Every time I have a square root inside a fraction, I always make a typo, where I put the curly brace in the wrong place. And then everything burns. Oh, root 2p, that's what you meant. Yes, let's just say root 2p. Okay, so, do I just square? I feel like I just square at this point, right? I don't know what else is gonna happen if I don't square. So, square both sides. Square root of frac p squared minus 1 over 4 plus 2p plus p plus p between x plus y plus 2 root xy between 2p. Wait, there's a 2, so this actually goes away. P squared minus 1. This looks a little familiar somehow, but I can't put my finger on it. I feel like I've seen expressions like this somewhere before. Anyways, that's not a point. Is this some sort of smoothing argument? How would you smooth? Fix the sum and change x or y by 1. I feel like because it's bounded both above and below, I'm a little skeptical. It's like I don't like if I had x and y with fixed sum, I wouldn't even know whether to push them closer or pull them further apart. It's like either one seems like they would cause it to go outside the interval. Should I square again? Should I square again? Why not factor? Factor what? P minus 1, P plus 1? I mean, already it's P minus 1, P plus 1, but I don't see why that... Thank you, Useless Taco 14 for the follow. I guess I just square. I'm not sure what else I'm supposed to do. P squared minus 1 is now less than... Like, I wanna... do I just get rid of all the radicals? It feels not elegant, but I don't see where else to go. Wait, how did that get typeset like that? Okay. Why not work with x plus y plus 2 root xy at most 2p? Yeah, I want to basically I want to sandwich an integer between two integers is roughly the line of attack. And so this is looking really bad. Okay, x squared plus 6xy plus... Oh my god. Oh, what is this? Oh, Jesus. 4. This is so bad. It doesn't even fit on the line. I mean, I can make it fit on the line by rearranging these things. Alright, I don't like it. I feel like I should be able to do something better than this. This is really unfortunate. But on the other hand, like... Like, the integers don't play well with the square roots, so I feel like I have to get rid of the square roots. Somehow. Um... Yeah, this is getting really messy. Okay, so let's let s equals x plus y and t equals x times y for brevity, because this thing is getting really gory. And so... like... integers and square roots are as annoying as floors. Do I just force my way through? I don't really want to force my way through. But something's off. Jesus fuck. I wonder if... oh my god, for frick's sake. Because what happens in the equality case is that this whole thing vanishes. Like, it's actually an integer if x plus y equals p. So I wonder if, like, if x plus y is greater than p, can I just break it? And if x plus y is less than p, does something different break? If I just look at this... like, okay, let me write this. So, if x plus y is greater, if x plus y is strictly less than p, does something go wrong? Or if x plus y is greater than p. Let me try greater than first. I think that might be strictly greater than p. So if it's greater than p, then it's at least p plus 1. So this is at least 1 plus 4. Oh, frig, that goes the wrong way. 4 root xy equals 2 root xy plus 1 all squared. But on the other hand, it's supposed to be greater than, this is supposed to be worse than p squared. Alright, so now I have to make sure I don't manage to confuse myself, which is the thing I'm really good at doing. Yeah, I feel like we might be kind of like... So this implies square root of xy is less than p minus 1 halves. Yeah, I wonder if the argument will be something along the lines of like square root xy is at most like some number. So, you know, here, because they're integers, that implies square root xy is at most whatever the next square. I don't know what it means. So if x plus y is greater than p, but it could be the case like x plus y. What about the other case? If x plus y is strictly less than p, can I get a bound the other way? I'm gonna call this, give this a name. Let's call this like capital A or something. The less than or equal to case just follows from square root being concave. Which case? Oh, I see. Then too small. Okay. I agree. Yeah, if x plus y is strictly less than p, then it's too small. Just always. Basically, I just need to check that root p minus 1 over 2 plus root p minus 1 over 2 is, yeah, that's too small. That's good news to know. So if x plus y is at most p minus 1, then always too small. Actually, if it's less than or equal to p, it's, yeah. So we'll always assume x plus y is strictly greater than p. Okay, that's fine. So that means this thing has a positive coefficient, so there's a contribution of root xy. This is something, well, God knows what it is. This is xy. So we'll let x plus y equals p plus s, and x times y equals t or something. Then, so p plus s and t are related somehow. Really? Okay, maybe I can say what it is. Then xy. So what's the discriminant? B squared minus 4ac. So x plus y squared minus 4xy is supposed to be some square, which we'll call t. P plus s squared minus t squared. Okay, so then I can rewrite this. P squared minus 1 is somehow between s squared and 4 How did that get censored? So, okay, this is nice because it kind of cleans things up a little bit, maybe. Depends on what you mean by cleans up. What do we think is the equality case? So the equality case is s equals 0 and at t equals 1. So I want to show you can't have a solution with positive s. So this is looking better. We're sort of narrowing it down repeatedly until we get like just. Okay. Okay, so clear. S and T have opposite parities. Do I care about that right now? Probably not really. Also, this should be a 2. Yeah, this should be a 2. I want to use up one of the 2, 4, X, Y. Okay, cool. Any tips for breaking out of just subbing randomly for functional equations? It depends on the functional equation, I think is the right answer. Like, I don't know. Thank you, Mr. Video 12345 for the follow. Alright, so here we are. And we know that s equals 0, t equals 1 is sort of the quote-unquote canonical solution. Oh, there's a factor of s I can just divide out by s. So 2p plus s plus twice the square root of some thing. Okay, and because this is for xy, I don't expect the square root to be 0, right? So my goal was to show that for positive integers st and prime p, this inequality can never be true. So if I square it again, will I die? Is this tolerable for squaring? Okay. We have courage, let's square it and see what happens. I'm worried a little bit about signs. Because up until now the squaring was reversible. I think this square might not be. T equals 1, S equals 0 is the main case. I don't know, this is looking really bad. Okay, whatever, square. Oh, this is so bad. Like, what else am I supposed to do, though? Like, the problem is equivalent to saying that this can't ever hold, where S and T are non-negative integers. Well, I guess T is actually positive. Maybe? No, T doesn't have to be positive. T could be 0. Does that feel strange? Maybe I should be solving for the primers. Did you figure out the prime condition is there? Not yet. I wonder, like, if T is a fixed number, does it do anything? If it's composite, you can have it be equal to 0. If it's like odd composite, I guess. That seems like it's important to know actually. Like, yeah, that's true. That's something I should pay attention to. So if P was not prime, for example, then let's say like P equals like, I don't know, 9. If P equals 9, then like x, y equals 2, 4 is clearly optimal. Oh, sorry, 2, 4, no, 2, 8, 2, 8. And this is the case where s equals 10 and t equals... What is t? 10 comma 6. Ten comma 16. Does that happen for every composite? I think so. Like, well, sorry, not every composite, but like if P equals 25, then XY equals 2 comma 32, or XY equals 8 comma 18. Yeah, and both of them will hit like, both of them will hit this on the dot. Like this number will be a square. But is the proof easy? Proof of what? That it happens for every composite? I don't know if that happens for every composite. It happens if like P is an odd square, or like a multiple of an odd square. I don't know if it happens for like, I don't know what happened if like P was like 15 or something. Yeah, P equals 15 won't be exactly that, but I don't know if it will be like equality is achieved at like 7 comma 8 precisely or something. Graph the points. What would you get by graphing them? Am I right? We're trying to prove p minus 1, p plus 1 is the best case. Over 2, but yeah. You want p minus 1 halves and p plus 1 halves. Is what we think the answer should be. I really don't want to square both sides of that. How many times have you squared so far? We squared twice. You need, yeah, 3 times would eliminate all the squares. Okay, we're gonna let m equals t squared minus 1 all over s minus 2p. T squared over s minus 2p plus s. I don't see a choice. I'm gonna square it. I'm gonna call this capital B. So this is b minus 1 over s is strictly less than. So what are the examples? Let me figure out when p equals 9. This is an important test case for me. S comma t equals what is this? What are s and t? S is the sum, and then t is the discriminant. Discriminant of this quadratic is 36. Or sorry, this is s equals 1 and t equals 36. No, not t equals that. T equals 6. So like STP equals 169 is an interesting triple that I want to see what happens. Because it will actually, b squared will exactly equal this. And this happens because... Well, more generally, if p equals k squared, I better write. I'll do this in general. 2k squared, 2k minus 1 squared, then 2k k squared. Should be able to write that. No. It's 2. 2 squared minus 4k. What am I doing? 2 times twice. Oh, for fuck's sake. S is k squared. Four, a squared, b squared. What is p plus s in this case? Hang on. Someone please compute this for me. Oh my god. Maybe I shouldn't have used these variables. Maybe I should just leave xy, because I feel like changing it to t made things more confusing. Because I feel like it made a lot of terms appear, and maybe that's not what I want. So let me just remember that later, and so xy equals u, and so this all this piece plus s squared minus. Oh no, but I want to get rid of the. Jeez. Well, okay. This is the official solution? Yeah, I don't know what I'm doing. I'm just making stuff up. Thank you, LMC, for the follow. Okay, so p squared minus 1 minus s squared plus u is 2s root u. And this is supposed to be less than p squared minus s squared plus u. Is there a way I can simplify p squared minus s squared? Because x plus y is equal to p plus s. Thank you, Bestana SMB, for the follow. Whatever. Okay, so it's between two perfect squares. Whoop-de-doo. Unfortunately, in all the equality cases, u is actually a perfect square. So maybe I want to show the... I don't know. I have no idea. What am I doing? So what are the equality cases anyways? It's like 2a squared minus... It's a minus b squared, right? And u is equal to 4ab... 2abl squared. Okay, so... This is in terms of PSU, and my condition on u is that p plus s squared minus 4u squared no, p plus s squared minus u is a square, which what the heck does that do? I don't freaking know. Look at root p over 2 minus root x. What does that do? want its values to be far from each other? Do we? This looks so much like Pythagorean triples stuff, though. I gotta say. I mean, yes, that's equivalent to the problem, but I just like don't see the advantage of phrasing it this way. Like, what becomes more natural in that phrasing that we couldn't have done already? I don't understand. Problems that x and y might be far from each other, comma bounding. Ah, jeez. Every time. Yeah, I don't know. Someone just give me like actually, this is definitely a real NT. But oh man, I don't like. This is such a. Yeah, I still think, yeah, so, like, for integers sk and prime p, we cannot have, does every year have an innate? No, but most years do. This is what the problem statement boils down to, which I feel is surprising. I'm gonna reintroduce t. I feel like I need a t. t is minus u is to p plus s a squared plus b squared squared minus 2ab squared. This is such a weird setup. This is gonna bug me. If I don't solve, like the problem is like problems that say that any like certain equations don't have integer solutions really bug me. Like if I don't finish them, I feel really very uncomfortable for the rest of the day. And this is one of them. Squared, it's 3 squared plus 2b squared. So wait, I feel like I'm having trouble. I don't know if I'm just tired or something, but I can't verify that this works. So, and I plug this in. A minus a squared p plus s is a plus b all squared plus 2a squared plus 2b squared, and then there's an a squared minus b squared. So what is this? Yeah, there's some I think there's some I feel like there's some Pythagorean magic happening here, and I can't pin my finger on it. But there's like these are Pythagorean triples. It's this thing. This is like yeah, there's some Pythagorean magic happening here. So you're telling me if p is a prime, I can't have this equation. And then there's oh shoot, I forgot the square. That doesn't that bug you? Like, there's no way this. Like, you look at this and you're like, why is this true? I'm really frustrated. I have P on both sides. I really don't want P to be on both sides, but I don't know if I can do anything about it. Like, if I could somehow have gotten the P out, then that would be amazing. But I don't think it's gonna happen. Expand to erase the p squareds. Oh man, I just don't want to expand. I've been trying to avoid expanding. Yeah. But I feel like I expand when I remember I'm desperate and I don't have any other options, and but like even when I expand this, like it's not like the piece card goes away, right? Like yeah, like what do I do with this, right? I was here a moment ago and I decided. Uh, 2s squared. What happened to the Pythag idea? I mean, it wasn't actionable. It was just I could feel like there were Pythagorean triples happening, and I couldn't see what you would do with them. Like I saw the Pythagorean triples that were happening in the equality cases, but I couldn't act on them. Although, okay, I feel like this was a different equation than I got last time. So maybe last time I made a calculation error, so it's good I did it. S squared plus 2s root p plus yes, yeah. Huh, that's different from last time. I think I dropped a factor of 2 or something. Okay, sure. Is there no reason to factor the part inside the square root? I guess we could. P plus s minus t, p plus s plus t. Yeah, I have nothing. P plus s equals x plus y, yeah. Yep. Yeah, I wanted to take out the... Because you see that like the natural quantity appears as x plus y minus p, and we know it's non-negative, so I figured it'd be better to let that be its own variable. I guess maybe that's not. I don't know. We could change it to like this is a variable, and then this is just like. I guess now that we're here, we could change it. Yeah, we could redo the variables. Okay, so let r equals p plus s. So we have. Oh, that's interesting because it finally isolates p. Cool. Okay, cool. So this is like z minus p or something. You're right. That actually finally. This is some. We're given that this is greater than or equal to p. Well, actually, it's strictly greater than p. So we find it to get z minus p like outside, which is something that's been bugging me the whole time. Okay, sure. Multiply by the conjugate, that gets rid of... Okay, so 2z minus t, this is a weird equation. Yeah, that's a good point. Like, we actually want to get outside the square root. So apparently this is true. Why is this true? I have no freaking clue. But the claim is that there is no prime that is between two that is like... Oh, I forgot the... I typed the square root. If I haven't made any calculation errors yet, which is very dubious, this is apparently true. Why? I don't know, but apparently... Okay, I better debug this. So, make sure that I haven't screwed up yet. Here z is equal to s plus p, which is 2a squared plus b squared. Oh, Jesus. I feel like I messed up. This wasn't 2p, so z squared minus I dropped a 4. This is a 4 in front of it. Those freaking 4s. Sorry, so this is actually checkout. No, it doesn't check out. I messed something up. Yeah, this doesn't. T is like too. This is too big. They're supposed to basically match up, and they don't. Okay, so what did I do? When I multiply by the conjugate. Oh, there's an extra factor of t squared I dropped. Actually, this should all be over t squared. Okay. And this should be. Okay, well actually that actually makes things nicer. This guy's like z plus root z squared minus t squared, and this guy is z plus root z squared minus t squared plus z plus. Okay, so after a lot of pain and agony, I think this is where we are. I don't think so actually. Hang on. Okay, so what did I do? I multiplied by. I multiplied this guy by this thing, and there was some t squared, so this is 1 minus t to the minus 2, and then this is like, it's just that. What are we trying to prove this is true? We're trying to show this inequality never holds. The end. That's the entire problem. All I've done is like repeatedly manipulate expressions in the hope of getting something that is like passable, and have been mostly unsuccessful, although this most recent one looks a little more promising. I don't think it's a tier. I think it's just one. Yeah, I mean, yeah, so where A is like expression. So, okay, let me really double check that I did not screw up the calculation, because if so, I'm going to be extremely upset. I don't think I did though. I think this is okay. Squared, 2s squared, and then 2s. Okay, so reduce to let z greater than p be an integer, t at least. Then z plus root z squared. A less than 2p less than a plus 1 over a, where a is equal to random quantity. And equality cases that we have are, or quasi-equality cases anyways. So we know there's a case where z equals what? P and t equals 1, was it? Then this is true. It's supposed to be true exactly. What did I mess up? Yeah, something's off. Zero. When z equals p and t equals 1, it's supposed to be sharp, but it's not. Z equals p, t equals 1, t equals 1. This lower bound's messed up. So z equals p and t equals 1. In that case, this should be... Oh, maybe it's okay. Oh, it's actually okay. Okay. Z equals P and T equals 1 is an equality case. And also we saw Z equals 2. Z equals P equals A squared plus B squared. Z equals 2A squared plus B squared. This is not technically legal because of course that's this makes P not a prime. T equal, and in that case I saw that T was equal to A squared minus B squared. And that will get the... How can this even be true? A is not an integer. A is like something. Why is it harder? Like A is not an integer. Yeah, yeah. We'd be done. It's funny because in the equality case, A is actually a bona fide integer, but it's not here. Oh my god. Freaking. Okay, so what is going on? Yeah. Okay, so why is this true? I have no freaking clue. Okay. So if A is actually an integer, then we're dead, right? Evan, isn't it past midnight? Why? Because I'm still stuck on this freaking edit. I feel like I finally have something that looks workable, but I don't know what to do with it. It's like, why would this be true? It feels like I should just be able to like pick some random large Z and T. Is Z greater than P implied actually? Like, is it? No, it's not. It's just, it means the... I'm surprised. Why is this statement true? Like, how can this be true? Yeah, that seems like the strat. If I pick some... think z greater than p should be implied. I feel like if z is... If somehow you had something to satisfy this, but z was less than p, it would be not big enough, right? Yeah, if z is less than p, I think this term, there's no way it catches up. I don't need to prove that rigorously, but... We commented earlier that something, it didn't feel right if... We had a comment earlier already that the case where this is already that. So I probably don't even need that. So it's just... I have these random numbers, and then for some reason there's never a prime near them. This is a strong statement. Yeah, ASM. Yeah, I almost want to look at like fractional parts or something. Like it's saying the fractional part of z squared minus t squared is really close to an integer because the other guy is like just barely over it. I don't know what to do with that though. Is p positive or bigger than t? P is a prime. There's no restraint on... I mean, okay, like, t has to be less than z because otherwise a is not defined. But yeah, t is strictly less than z. Yeah, let me just write t. Yeah, like a test. Yeah, 1 over a shouldn't be very large. So I don't know. I don't know what you do with the square roots. This is where we're at. I think this is like the clean statement, but. Yeah, 1 over a is small. It's worth writing, I think, a as like... There's a couple of forms that you can write a in. One is like the raw form here, where it's like t squared minus t squared. But the other you can write it as t squared z minus square root z squared minus t squared. Not clear whether one of these is an advantage over the others. Can we use calculus now because it's reals? I don't think so. You still need integer condition. Like, what would you do with calculus? This just bugs me. Like, it's saying this is a... If your fractional part of z plus root z squared minus t squared can't be too close to an integer, can Can I bound that? Like, I guess, how close can a square root be to an integer? I guess maybe that's what I should think about. Like here, can I even do the case where t equals 1? Can I show the... Yeah, exactly. So, yeah, there's some bounding I can... Like, so... Like, the distance from... If a is not an integer... If a is not an integer, then there is... Then we have a bound of like... So z plus root z squared minus t squared is not actually just strictly less than 2p. It's less than 2p minus 1 over... What do I want? Something like that? Like the distance from claim n minus root n squared minus 1. The distance from a number to an integer blah blah blah. Well, okay, so this is like... Okay, so this is like 1 over n plus root n squared minus 1. So it's like... Does this not just work? I hope it works, because then I want to be done with this problem, dang it. 1 over 2n... So this distance is at least 1 over 2n minus 1, right? Okay, so since z is greater than p, this thing is like some square root... Yeah, so like p minus 1, right? Then we have a bound of like California speak. Because it's like yeah, the square root bit is at most the thing I wrote. A modified factor of 2. So let me just then using... Then since z greater than p, the... Okay, so that 2p minus 2 minus 1, I guess. Wait, can I just write 2n here? Oh, let's just write for simplicity 2p minus 1 over 2p. In which case, we hope we cross our fingers and pray that a plus 1 over a is good enough. Maybe I need I might need the minus 3 after all. Does that work? Wait, is this gonna work? So obviously you need a to be greater than p minus 2p minus 1, or else it's never gonna happen. If a is not an integer, then since z is greater than p, the square root is... So you get, you know... This is some distance from the nearest integer, the integer right above it. So it's like 2p minus 3. And I think this is good enough. I think once I feed the -1, I'm fine. Because a plus 1 over a is yeah, this is like less than 2p minus 1 over 2p minus 3. Plus 1 over 2p plus 1, which is definitely less than 2p. So if a is less than 2p, then a plus 1 over a will be less than 2p as well. Okay. So since z is strictly less than p, equivalently z is at least p plus 1. It follows that the square root bit z squared minus t squared is strictly less than whatever square it's trying to approximate, right? So the fractional part of this will be always worse than that. Like the fractional part of the square root is, yeah, z is strictly greater than p. Okay, does that work? Did we make it? Can I go to sleep now? Oh my god. Wait, I think I flipped something. Oh yeah, this function's bigger. Bigger, smaller. It's so confusing because it keeps flipping over and over. Oh my god. Ah, garbage. I can't believe that worked. Why is an estimate rigorous? What do you mean why is an estimate rigorous? Like, is this not rigorous? Okay. Let me double check the... I'm gonna double check the AOPS, but I think this should work. Okay, what year was this? 1998. I don't know. I really felt like it had to be that or something. What was the year of this problem? 1995. Yeah, it's calculation. Okay. Alright, I think this works. This should work. Yeah. I'm glad I had the equality cases so I could debug, so I can be confident that I didn't screw up the algebra. Because otherwise I'd be paranoid as heck. But because the equality cases are preserved the whole time, the algebra should be okay. And once it's down to this, the idea is that square roots are not... They don't approximate integers that well that you can do something like this. So A definitely has to be greater than 2p. A is definitely greater than 2p minus 1. And this bit here is trying to approximate something that's at worst p minus 1. Like, the worst thing this could be is p minus 1 minus 1 over p minus 1. Sorry, there's no minus 1 here. Why did I put a minus 1 there? Go away. There's no second -1, right? I switch to n. That reduction, useful to know. Well, I feel like it had to be a reduction the whole time because you know that it's something about integers, and like what are you gonna do with integers and square roots? Like the other alternative is you could try to cite some fancy stuff from like algebraic number theory, but the problem is that they're also inequalities. So I don't know. I was just like. I've just tried to get rid of the square roots as much as I can, and eventually I got to something I'm like, I can't square any further, but this is pretty good. And the whole time I make sure like the inequalities feel right. Like all the inequalities should be a statement of the form some number is between two very narrow quantities. And when you got the right one, you're good to go. Incidentally, this shows that the p prime is not really used other than to block the edge cases where, you know, I think the p prime is used to say that z is strictly greater than p, so you can't have like t equals 0, z, or whatever. Or, yeah, you can't have this exactly equal to 2p. Because then it looks like that case. But I don't think it's used beyond that. Okay. Alright. Well, we still didn't get to Jadon's problem. Once again. I think I think at some point I might just like override the vote because I want to do the problem, but we keep getting blocked by random n6s and n8s that people keep voting up instead of. Alright. How long did I spend on this? Where's the voting? The voting happens at around 8:30 Eastern. Like the first half hour of the stream is me goofing off to like kind of let people trickle in and play FTW, and you know, sometimes the US server isn't working and I need to reroute my Twitch stream to Australia like today. Actually, like 2 weeks ago it was like, yeah, 1 week or 2 weeks ago it was like, you know, Linux just apparently Linux 5.9 is not compatible with NVIDIA, like whatever version. So it was just like, well, crap. And then I had to like reinstall Linux. And then today, it's like the US server isn't working and I have to like route my stream through Australia because otherwise there's like a 10-minute ping time, which is like unacceptably bad. So now I'm routed through Australia, and I no longer have dropped frames. And why I need to route through Australia, the world may never know. Although Twitch.tv seems to be responding to me again, so maybe it's not so bad. I don't know. Oh, I was pinging Twitch.com. I don't know. MIT PhD? Wow, you are smart. You should see the other PhD students. Holy crap. The other PhD students actually know math. I just like pretend to know math and then do like high school Olympiads.